In this video, I'm going to walk through a simple derivation of the work-energy theorem, just using some basic calculus. If you don't know what work and energy are, that's fine. I'll try to prove everything from first principles, just using basic kinematics and dynamics. Let's first start with a simpler question. How does velocity depend on position? Well, the definition of velocity is the derivative of position with respect to time. So our question, in calculus terms, is what is dv dx? To solve this problem, we're going to use the chain rule. So expanding out, dv dx is dv dt times dt dx. But we know that dv dt is acceleration, and dt dx is 1 over velocity, since dx dt is velocity. So it seems that the derivative of velocity with respect to position is acceleration divided by velocity. This isn't a very satisfying result, though. What does this exactly mean? Let's just play around with this equation that we have. Cross-multiplying, we find that v dv is a dx. Now, we'll multiply by mass, since that gives us momentum and force, and those might be easier to work with. And it looks like we're ready to integrate. We'll also assume that mass is constant here. So the integral of v with respect to v will be v squared over 2. And if force is constant, we just get F times the delta x on the right-hand side. And there you go, the work-energy theorem. Except we haven't defined work and energy. Let's expand the left-hand side, and then we'll call the value 1/2 of m times v squared kinetic energy, and we'll call the force times displacement work. I should note that this F times delta x formula is a little simplistic. The more complete formalism of work is that it is a line integral of force with respect to position. Essentially, we will track how much of the force vector aligns with the path along infinitesimal portions of that path. Also, if you have multiple objects, the total kinetic energy is just the sum of the individual kinetic energies. And there you have it, the work-energy theorem. I'd like to thank Grant Sanderson from the YouTube channel 3Blue1Brown. The code for creating the animations in this video came from his open source repository, which will be linked in the description below.